I'm Ruse from Gradle, and this is DevProdEng Lowdown webcast, where we have a nice conversation with folks in the industry that are doing really interesting stuff around developer productivity to kind of share that in their journey and their stories and wins and best practices with the community. And for this event, we're really exciting one. We're talking with Guillaume here from the Quarkus open source project. We have, he's one of the principal engineers on there. Also from my side, we got Jerome on the Gradle and Develocity engineering team that was working very closely with Guillaume on his project. And we also have Brian here, one of our developer advocates, and he's the Gradle team's Maven expert. And he knows all things Maven. I've known this gentleman for a long time, just from the JVM circuit here. And we have some really interesting topics. We're going to talk about Quarkus and how Quarkus runs builds and tests. And we're going to talk about their developer productivity journey. And very excited about this one. Quarkus, their Maven build is super complex. I mean, it's a beast. And this journey was just very exciting. And Guillaume, when I first spoke with you, I was like, wow, we got to share this with the world. And Jerome brought it up to me first. He's like, hey, we got to get Guillaume and everybody on Lowdown and share their story. Guillaume, let's kick it off with, why don't you tell us a bit about Quarkus and how Quarkus does builds and tests?
Yeah, sure. So let's have a look at what Quarkus is, how we are building it, and the fun that we are having. So the first thing is to explain why we did Quarkus. The first thing is that Java is getting better, and Java is also getting very different from what it used to be. So we are now building containers, which are immutable. We are not pushing dynamic jars after having started an application server. We don't have the long-running application servers anymore. We are trying to live in a container world, which means that they are immutable. And also that we have a closed world, meaning that we know everything about the application when we build it. And I won't say anything about this image, but it's really about how we are trying to put Java inside the container world. So here comes Quarkus. So Quarkus is not about microservices. Quarkus is not about serverless. It's really about everything. So you can write any apps, any Java apps with Quarkus, a monolith, a microservice, Lambda, GitHub app, a GitHub action, whatever comes to mind, you can do it with Quarkus. You can do CLIs. It's really a stack for everything Java. And the promise of Quarkus is that we are faster and we have a smaller memory footprint. And it's not magic. It comes with the fact that we moved a lot of things from runtime to build time. So when you use a traditional stack, a traditional Java stack, you do very little at build time. You basically build a jar. And then when you start your app, you are going through the XML files, configuration files, the annotations. You build a model, and then you start your application. And with Quarkus, we are changing that, and we are doing a lot more things at build time. And so we are scanning the class path, we are reading the configuration files, the annotations, we are building a model, and then we put everything into a jar, mostly with generated classes. And when you start your application, it has a lot less things to do. So it starts faster, but also the fact that typically you don't have to parse any XML file anymore, or YAML file or whatever. You can drop the XML parser from the runtime. You don't need it anymore, so you can drop it. So it's smaller, the footprint is smaller, and you also get a far smaller binary, typically for native images. And it really has a lot of sense in the context of native executables, but you shouldn't limit Quarkus to native executables. running Quarkus in JVM mode is really nice. And yeah, we encourage everyone to actually try it. What we try to do with Quarkus is emphasize on DevJoy. We have a lot of APIs that make things easier for the developer. We have what we call the dev mode, which allows you to start your app and then do whatever you want with it, and it will just roll out the classes without you having to do anything. So you start your app once and then you code and you refresh and it's all deployed again. So it's really, really handy when you develop. We have continuous testing, so you can start your tests, you change your classes, and the tests are run automatically, and you get a status for that. We got DevUI. We already got a lot of developer tools that make the developer experience a lot better. So we started our Develocity journey because basically our build wasn't scaling well on GitHub Actions. We had some jobs that were taking a lot of time. Our build is very complex. We will see that. And so we at some point, someone from Gradle actually contacted us and said, we have something for Maven too, and we can offer you an instance of Develocity, and it supports Maven. So you could try it in your build and see how it goes. And that's how we started. And so you have to understand that the Quarkus build is massive. So this is a core repository. Only we have a ton of extensions which are hosted in external repositories, which we call the Quarkiverse. So the core repository is more than 1,000 modules. And even if you build in parallel locally with MVND on a beefy laptop, so you get rid of the test and you just want to build the stuff, it takes 5 minutes. So it's a lot for, the feedback loop was really long, and we had to improve on that. The other issue that we had is that our CI was saturated. We have quite a lot of nodes. GitHub was kind enough to provide us with a bit more than what you get for your usual org. But still, we were having jobs taking 5 hours, sometimes even more, 6 hours 30. And the limit for GitHub Action is 6 hours. So anytime you go further than 6 hours, your job is simply canceled. It's parallelized, and the total runtime for a full CI run is more than 24 hours. So obviously, our CI load is massive. And yeah, that was the big issue. So if you have a look at our CI run, we have an initial build that basically builds the tree. Then we are calculating what we need to build, and then we start all the jobs. So we have the JVM test. So we are running the test for Java 17, Java 21. We have the Gradle test, which are separated. We have the Maven tests, they are also separated. We have also all the native tests. So Quarkus supports GraalVM, and compiling a native executable on a fairly slow native builds into. And if everything is like 43 jobs running in parallel for one CI run. And so that's how it started. We were basically in a situation where we were too slow. CI was in the way for us to make progress, and we needed a solution for that. And that's how we started working with Jerome, Nelson, and Gasper from your team.
Yeah, well,
yes, exactly.
What a journey and what a crazy. And Jerome, I mean, you've been mostly working with Guillaume, and I can see kind of the pain points that brought us two organizations together. Jerome, tell us a little bit more about that part of the journey and how we started getting into kind of instrumenting and looking into the insights of what's happening in the Quarkus build.
So, yeah, I mean, first off, let's take a step back. And this is sort of a regular process, right? We are partnering with some OSS foundations. In this case, it was Red Hat. And when you're given or hosted a Develocity instance, then you are not like, you're not alone. We come here and provide some assistance in order first to start publishing your build scans. But then you want to go beyond that. You want to optimize them. And we are here to assist as well. So again, we've got sort of a regular process. We've got some what we call experiments that we can run together. So we had those recurrent meetings where we start to know each other, I would say. Those were some weekly meetings. So first it was about running the experiment, which is basically running your build twice. So in an isolated environment, assumption is that the first build will populate some cache entries, and the second build, which would be run without touching anything, without changing a single line of code, should get some caches for all the cacheable entries. And you explained it thoroughly, Guillaume, is that your build is not trivial. And our regular process doesn't really apply here. Because, when you consider the way you can build Quarkus, it's already super complex, right? You've got a matrix of combination of JDK versions, OS. You've got you already considered optimizing your build, and you are using Git for incremental builder. So depending on what type of change you are actually putting on your change set, you might have some modules included or not included. So just understanding where to start, which build, how we should run the builds that would be used in order to run those experiments was a complicated story. But we went that first step, and then agreed on what we should consider first, and started with those experiments. Feedback was slow because you mentioned it. It was a very long build, but with this approach. With this approach of running twice a build and looking at the cache misses and going iteratively and trying to troubleshoot, you can go and optimize a build. This is what we decided to do, and we've been doing that for a while because build is massive. So troubleshooting, analyzing that the results is just taking a long time.
Yeah, thanks for sharing that. And for the audience, right? We give Develocity, formerly known as Gradle Enterprise, to open source projects and work with them. Jerome's team is mostly handling a lot of that. Work with them to instrument it, and all these are public, and you all can go check out the Quarkus Develocity instance, look at their build scan. This is all public for everybody to show, and myself and other folks at Gradle use these for demo purposes. So Jerome, you worked with Guillaume, you hosted a server for them, you started capturing build scans from all the Quarkus builds, and then you started running these experiments, as you mentioned. So what did you find? What was, of course, build caching and build performance was obviously one of Guillaume's main pain points and focal areas, but what did you all find, and what was interesting?
Well, the nice stuff is that when you start applying the Develocity extension to your build and enable cache, is that you come with a set of goals which are already cacheable, built in the extension, if I can say so. So you should get some immediate benefits. However, in this case, we immediately found some problems in the way, I would say, and Maven version was the first. An aligned Maven version will prevent you from getting any cache hit. So we had first this initial step of making sure that builds were using the same Maven version. So you've got some techniques for that. You can use the Maven wrapper, and we've been generalizing this to your CI base. So this was the very initial step. Once you're there, you can discover some more actionable items. And usually, and I would say as always, test is the one where you want to see some optimization, because they are the one which are usually taking or dominating your build time. And there were some problem there. And you've got the full list of usual suspects, right? absolute path, which would be different between CI and your local, timestamp in a manifest, which may be helpful, but going in the way of the cache, right? If you've got a timestamp in your manifest, and it will change build over build, and yeah, you can't get a cache hit due to that. So we had to go little by little, step by step, fixing those and improving our cache hit ratio, right? Until trying to get to a better situation in terms of overall build time, reduced thanks to caching. I mean, we've got a lot. I mean, I can't reduce like more than 1 year collaboration in 5 minutes, but yeah, those were the most impactful items that were found very, very early.
Yeah,
1 year. Wow. I didn't know that.
Another area of improvement was that we wanted to improve the local feedback loop, meaning that you don't run the test, but you just want to deploy Quarkus locally quickly. And this was relatively slow. And so you have a remote cache, which is used a lot by our CI, but you also have the local cache. And we also had, and even with the local cache, things were still slower than I would have wanted. And what's nice with Develocity is you have a full picture of your build. And when you are building such a tree with 1,200 modules, you have no idea what's going on because you can't really go through your logs and try to understand what's going on. So you can have a look at which modules are slow. This is relatively easy. But having a look at actually which goals are taking time and which goals are problematic, you can't do it without the overview that Develocity offers us. So we typically, for instance, we had split our enforcer goals in small units because we wanted the various rules to be separated and easily maintainable and things like that. And in the end, just the initialization of the enforcer plugin is relatively slow in our build, probably due to its size. And splitting things actually slowed us down a lot. So I actually, instead of having 6 enforcer executions for each module, we now have 1, and it's a lot faster. So we actually not only worked on caching, but also worked on improving our builds and how it was structured and how it was run to make sure that the local feedback loop was also faster than it used to be.
And how much faster did that get just from, working on these?
So locally, at least on my laptop, so let's take my laptop as an example, the build used to take 5 minutes. So the full bits without any tests or whatever. So with a lot of things disabled, we don't generate the doc or things like that. So the build to get your new Quarkus build installed in your Maven repo, and you can test it and play with it. With all this work, we went down to 1 minute. So it's a 5 time improvement locally. And we still have work to do because for some of the goals, we weren't able to cache them due to some specific Quarkus annotations processors, which are not exactly cache friendly because they are generating their outputs outside of the module. So really something you shouldn't do. And we didn't have this Develocity talk when we did that. So we need to work on that and fix it. And once we will be able to fix it, that means that we will be able to cache a lot more of compiler goals. So I expect it to be even faster. So really the local feedback loop. And I mean, 5 minutes, 1 minute, you would say that it's relatively similar, but it's the difference between you have to switch to something else and you can stay focused on what you are doing. So in your day-to-day work, it makes a real difference.
I mean,
let's have a look at some concrete. Sorry, just 1 minute. Let's have a look at some concrete numbers. I think we've got some material here which can just illustrate that perfectly.
While you pull up those slides, it was funny. while Guillaume was talking, I just pulled up the Develocity instance of Quarkus, and I just filtered by local builds, clean install, and I saw even some clean install local builds. The best case running as fast as 17 seconds. So that's pretty cool.
Yeah, so some people have faster machines than I have apparently.
Or they may ran a build without making any changes.
Yes, or they are, well, they are maybe building some parts of the build. I don't know, but that's, I mean, the rule of thumb for all the experiments I did was really my laptop, so I focused on that. But all my metrics are really about how it is on my laptop. But we deployed it to the other team members, and we all have seen really great improvements to our builds.
Thanks for sharing. Jerome, tell us what we're looking at here.
So yes, I mean, you see just pictured the improvement that you're getting through remote cache. So you've got the average build time. So this is after optimization. If we had been looking at that 1 year ago, it would have been way longer, I would say. And you can see in the part below, in the second chart, the avoidance saving. So it's a time not wasted, not lost by executing some tasks. So by getting a cache hit, which is illustrated by those gray bars. So the higher the gray bar is, the more you get from the remote cache. So you can see those gigantic gray bars, which are super. I mean, illustrating the best cache hit ratio. But you see all that being scattered. You've got some builds benefiting a lot from remote cache and some others which don't. I mean, this is not a problem because you don't want to get cache hits every time, right? If you apply a code modification, what you don't want to get is a cache hit. So it's just normal. This is the way it is. And with a lot of contributors actually creating some PRs in parallel, this is just normal to see this sort of scattered graph. But we've got some illustration of what you can get from the cache. And the beauty of it is that with our experiments, not only we were able to improve the local build time, but CI as well. And I think we've got an example, if not mistaken. Yes, exactly, which actually illustrates what you can get in CI and what you can get in local as well. Because on CI, you are interested by, consuming less resources, maybe staying within the 6 hours timeout limit from GitHub. But in local, maybe you won't be running this 4 or 5 hours build. But it makes a difference between a 5-minute build and a 1-minute build. Context switching here is just like a no-brainer. When it's a 1 minute, you can remain on the same topic and move on, right? So yes, that's just demonstrated. And here it's illustrated through caching, but we've explored other areas. We've been exploring some more because with caching we got some tremendous results, but we decided to go the extra mile, and we've got actually some other ways to achieve build time improvement, and one of them was predictive test selection. So not sure if it's relevant for me to elaborate too much on predictive test selection, but just maybe in a sentence, this is a machine learning based process which actually helps to skip tests based on test history. So just to give an example, if your test has passed under the same conditions within the last 50 execution, it's highly likely that it's not relevant to run it again, right? On the other hand, if you've got a test which actually failed when you change this .java file, a source file, whatever, well, rechanging the same file, it might be relevant to run this test again. So with predictive test selection, you can actually skip some tests. This is a very simplistic way to explain it, but this is basically how it works. And here we've been actually enabling predictive test selection on the Quarkus build as well to actually accelerate the test goals, the test phase, which proves some results you can see in the upper screen. This is where it's actually used. So we've got some, it's narrowed down to a limited scope because we didn't want to put it everywhere for the moment. We want to have our changes being applied iteratively. And we see quite some potentials in the screen, in the chat below, where you see that you can get some massive wins if you start expanding that to much more modules. So here it's not narrowed down. This is to all the list of build, but you could see that you could maybe save on the last 28 days, over the last month, close to 70 days of CPU time. So due to the number of tests that are run, this feature is actually super valuable, or could be super valuable if we expand its usage. So this is about predictive testing.
Yeah, that's pretty awesome. Last time when I chatted with Guillaume, it was a few months ago. You all hadn't done this yet, so exciting to see that the progress that you made here. And I love that last slide of the timeline view. I mean, that's a beautiful Maven build. I mean, Brian, how many of those, you've been in this Maven world for a long time. I mean, look at the timeline view of how well that build is parallelized on the second image there. Brian, what are you seeing in the Maven world? And, you've worked with so many Maven builds and many of our customers and, even before Gradle, this compared to that and what we have achieved, what are you seeing in the Maven world these days?
This is impressive, right? So a lot of folks don't even run their Maven builds in parallel, period, right? So just enabling that flag is a win in a lot of cases. But this really shows a highly optimized build. Obviously, there's a ton of modules here, so there's a little win from that all by itself. But most of the time when I look at one of these, it's a couple threads. There's usually some sort of like God module or something in the way that's blocking a lot of the other modules downstream. So this is definitely impressive.
And Guillaume, just to improve the local experience, where do you see, to take a step back, when we, Jerome and myself, we live in the Gradle build tool world. That's the world that we kind of come from. And it's the world of incremental build, single line code changes, and you get the super fast feedback. And then you have the rest of the world talking about shift left and how we want to do more tests locally. Obviously, doing a full PR build on a MacBook, a Quarkus full PR build with any type of caching, that fan is going to just go wild, right? That laptop is just going to fly out the window. But where do you see, with predictive test selection and whatnot, where do you see that this could go for you all, just improving the local experience?
Yeah, so to improve the local experience, so the first thing is what I said earlier, we need to fix this config doc build that is not cacheable because it's in the way. If you have a look at this build, you can see like the compiler mojo is still quite high, and because part of the build cannot be cached at the moment. So the first step is really to improve on that, and that we will need to rework this annotation processor. Next, we have plans to actually split, to reorganize our project to make sure that you could build a specific area without having to build the whole thing. And also it would be a lot easier to actually test a particular area. Typically at the moment, we have all the extensions in a submodule, and then we have all the integration tests in another submodule. So when you want to actually test a change, you have to install the extension, then run the integration test, things like that. It's not very practical. And so we want to reorganize this to make it a bit more obvious that you can run this module and it will run at least the basic safe tests that the closely related integration tests are run and you are relatively sure that things should work. So that is one area of improvement. mostly because also we want to. So Quarkus has always been an open project, but we want to open more. And when you have a look, you clone the project and you have a look at it, and it's just massive project. You might, I don't know, be a bit shy. And the fact that we will split things up will probably make it easier for newcomers to start with it and experiment with it. There are also, I think, a lot of improvements in the Maven world. Typically, I have this nice parallelized build because I'm using MVND, the Maven Daemon. And also we have some, I think we still have some improvements to do on the incremental part of the build. And that's how we are trying to make progress. We also will improve probably how we split the CI jobs to make sure that we are maybe a bit faster for the feedback loop on CI. So we have quite a lot of areas of improvement. It takes time, and also experimenting with such large builds is not that easy. So obviously, when we are doing changes, we have to make sure that they are bringing something to the plate, not actually slowing things down for some people. We had some examples of caching actually being detrimental for some people because they had slow I/O, very fast CPUs, but slow I/Os because of antivirus or local software slowing down the I/Os. So actually, it was faster for them to execute things rather than getting them from the local cache. So you have to find a balance, push things incrementally, getting feedback from the field, and then try to improve on that. And that's what we did for the whole experiment with Jerome, and that's what we continue to do slowly but surely to make sure that the project stays sustainable in the long run. We still have a massive number of modules, but you have to understand that we had more, and we actually moved some of the extensions outside of the main build. So we are slowly also moving some of the extension outside, both to make them a smaller project and maybe give the keys of these extensions to external contributors who could maintain them a lot easier and have a different release cycle, maybe faster release cycle. But we have a very fast release cycle for Quarkus. So, but anyway, that's what we are aiming for, is keeping the project sustainable in the long run, making sure that it's easy to start with it and experiment with it, and be able to actually test and contribute a fix and test a fix locally relatively quickly. That's our main goal, really.
Nice. Thanks for sharing that. And before we move off the build and test acceleration topic, Brian, we have a question from the audience.
Yeah, Sergey wants to know a little bit more about the Maven Daemon. So specifically, what are your impressions, and is it stable enough for your purposes?
So the first thing is that we are using it locally and not on CI, mostly because on CI we want to have a relatively manageable build and not having some weird parallelized thing. Also, we don't have that many cores on CI, so GitHub recently improved that, but we used to have 2 slow cores, and we experimented with the parallel builds, and it wasn't that much faster. Locally, I can say that it makes a big impact, both to make sure that our cores are well utilized by the build, and also it makes the fact that if you use the standard parallel build from Maven, the logs gets a bit messy with all the lines being a bit messed up. With MVND, your logs stay consistent, so that's very nice. From my experience, it has been mostly stable. Sometimes when switching from two old branches, I have some weird stuff going on, but I stop it and start the build again. And but yeah, I used to have a few issues at the time. Nowadays, I think it's really stable for our usage, and it really makes a very, very big difference. And just the fact that, so people might not know that, but just having your logs scrolling in your terminal actually slow down your build. So just not having a massive amount of logs being pushed to your terminal actually makes your build a bit faster. So using MVND and its clever way to deal with the terminal also helps with making the build faster. So I really encourage people to use it. So it has been a very nice experience.
Awesome. I will add that the Maven Daemon just went 1.0, and I think there's actually a patch 1.0.1 a few weeks ago. So if you haven't had a chance to try it out, go try it out. Give the Maven team feedback if you run into any issues. Hopefully you don't, of course.
It has been used at Red Hat for massive projects. The Camel team is using it. They have also a very, very large repository with a lot of modules, and they have been using the Maven Daemon for edges and contributing to it. So yeah, I think it's not perfect. Sometimes you will have some weird behavior, but really most of the time it works perfectly well. And it's and when something weird happens, it's easily. It's not like you will have your test or your build failing for a very weird reason, and you won't know that something is wrong is going on with the Maven Daemon. When something wrong is going on, it's very clear, and you just have to stop it, restart it, and you get it working. And also they are very reactive. So if you have issues, they provide feedback very, very quickly. And yeah, this thing has been improving a lot. And it's my daily tool for building Quarkus is MVND. I use it for mostly all my builds.
Awesome. Thanks for sharing that experience with the community. Next topic, we got two more. We'll get through these fairly quickly. You showed me some really cool stuff, Guillaume, on you all use GitHub Actions, and we all know there's a lot of community pain around, digging through the logs of GitHub Actions when you have these CI failures. And you did some really cool stuff with that. I want you to share like what you all have done with just with GitHub Actions and trying to get ahead of this, making it easier for developers to troubleshoot those failures.
Yeah, so it started with basically you have your CI failing and you have no idea if you can merge what's the problem or whatever. So you have to click on the particular job, and then we have very long running jobs. So you don't have the full log into the GitHub UI, so you have to download the raw log, let it download, it takes time, and then you go to the bottom and you figure out the error, and then you will have to try to find in the logs the actual log of the test that was failing. So that was a bit painful, to say the least, except especially since we have Quarkus is a very active project, so we have a lot of PRs coming. And also when you have CI running for 5 hours, you might have a Docker container not starting. You might have an infrastructure issue on GitHub Actions. You might have ton of issues that might explain a flaky test or something like that. And when you have to check every pull request to understand what's going on, it takes a massive amount of time. So what we did is that we have a GitHub bot, which is developed in Quarkus. We have an extension for that. It's called Quarkus GitHub app, and you can develop GitHub apps, and we have the same for GitHub Actions. So you can also develop GitHub Actions. So we every time a build is finished, we send the event to the bot, and the bot is downloading all the Surefire reports, the Maven build status, and it analyzes everything, and it gets you a nice report in a comment with everything you need to know about your build, which jobs actually failed. If it failed for GDK 17 and it worked for GDK 21, you will have an indicator that it actually worked for another GDK. You have the list of the test failures. You have the stack traces of the test failures. And when we started our journey with Develocity, one of the things I wanted to do was to also get the Develocity feedback inside this report. So we have a link to the build scans for the jobs. And also, Jerome pushed us out to actually enable the flaky test support in Surefire to make sure that we would actually try to run the test a few times if they are flaky. And I pushed back saying, yes, but I want people to know that they have flaky tests because it's important to know, and I don't want it to get lost into a report somewhere. So we also improved the Surefire report parser, the Surefire project, to be able to get the information about the flaky tests. And this report also includes the flaky tests. And it also has a nice link to the Develocity history for the test. So when you have a flaky test, you can click on this link and you end up in the Develocity UI, and you have the history of the test, so you can see if it has been flaky a lot, if it's a flakiness that was introduced by your pull request. So it's very handy. And so we actually invested a lot in our tooling, because it's such a massive project that if you don't have tooling, you can't manage it. So yeah, we have a lot of tools. All of this is open source, so people can use it and experiment with it if they want. And yeah, and they can come to us and ask questions if they are interested in all this.
Yeah, that's pretty awesome, man. Flaky test is a big topic here at Gradle. And one thing you mentioned when I talked to you, you were like, hey, just having this info and having the UI and having easy access for developers to look at the flaky tests and the test history and all that was able to, merge PRs faster. And when I talk to, engineering leaders, sometimes they're, too disconnected of what happens with developers on a daily basis. And they may not know the impact that flaky tests have. I mean, so how were you able to kind of make the case to say, okay, but this helped merge PRs fast? Because that's something that engineering leaders would definitely get their attention. How would you, if you wanted to share that with the community, how would you say that impacts?
Well, so the first thing is that we are we have a lot of autonomy at Red Hat. So when you think that something can make an impact, you can actually experiment with it. So of course I didn't work full time on all this automation at the beginning, but I actually made a few experiments with it to try to show what it could bring to us, and we quickly saw all the benefits for it. So it was relatively easy to actually convince people that it was the way to go, given the size of the project. And so for the flaky test, the thing is easy. Basically, for nearly every PS, people were actually pinging me because I was having a look at everything and asking me, oh, can I merge it? And so I had to basically come and say, and I have basically a buffer in my mind with every flaky test. I had them in mind. I was like, oh yeah, this one has been failing for a while. This one is new. You should have a look at it. And so basically you create, everyone was depending on me actually vetting the pull request. So obviously it slows down the process a lot. So that's really, when you work on a project, you should try hard to make sure that you can go on PTO and nobody actually notices. Then you can be sick and nobody notices, or at least the project is not slowed down because you are not there. This is important when you are working on a critical project. And we worked hard on that. And also you have to understand that what we actually experience at the Quarkus level, because we are at that scale. So I have a talk about how just small pain points can completely slow down a project. And yeah, really we saw it because of the massive scale, but even for small projects, you can't imagine the cost of context switches and the fact that you don't have the right data at the right moment, and you have to actually dig into things and switch context. If it takes 10 seconds to get the information, you do it right away. If you know that it will take 5 minutes to actually extract the information, you won't do it right away, or you will have to switch context.
There you have it, folks. The impact of faster feedback cycles. We've been saying it for years, and you get it directly from one of the largest projects out there, one of the largest Maven builds that I've ever seen. And thanks to everybody. We're going to start wrapping up now. If you want to learn more about Quarkus, my buddy Eric D'Andrea, he wrote a nice Quarkus book on it, and this we'll send more info to all the attendees for that, and we'll include that into the YouTube video that's going to go live soon, after our team kind of play this. So if you want to share this webcast or podcast with anyone, you can share that YouTube video. And for Guillaume, any for folks more interested in Quarkus, where should they go?
Quarkus.io, and really we are a very welcoming community. So we have a doc that is amazing with a lot of getting started guides, so you can experiment very quickly with Quarkus. You can see it by yourself, because you might not trust what I'm saying when I say it's fast, and when I say the developer experience is amazing. So just have a look, try with a small app, and you will see by yourself. And I hope you will get convinced. And if you have issues, come to us, open an issue, open a discussion. We are very open. We are very reactive. We release extremely fast. So whenever you end up with an issue, you will get a fix very fast. So yeah, really, it's a very nice community. So come join us and have fun with Quarkus.
Awesome. And Jerome, Brian, for Quarkus users who want to speed up their builds, or Maven users who want to speed up their builds, where should they go?
Well, I mean, actually, we took advantage of our close collaboration to not only optimize the Quarkus build, which was our main focus at first, but try to get that reflected to the community, right? And so that we've been collaborating on implementing this Quarkus build caching extension in order to make the Quarkus Maven build goal cacheable, meaning that you run it once, it can take up to, 5-10 minutes. You're downloading containers if you're using the inbuilt container strategy. That takes time. But starting the second build, the third build, it will get a cache hit, and you can save up to 5-10 minutes or even more, right? So yeah, we've done that for the Quarkus build, but that can be used by any project that is actually relying on the Quarkus framework and creating some native image eventually, obviously.
Absolutely. So it's not just the Quarkus build itself that gets faster, it's users of Quarkus, their builds can also be faster.
Yep.
And Brian, you have for our Maven users that want to learn more about build scans and whatnot. Build scans are free, hosted by us. For all Maven users out there, if you want to get insights into your build, kind of like what we showed today. And Brian, you have a nice webcast on this. I think on DPE University, you have a self-paced even training course on that, yeah?
Yes, I have a self-paced training on build caching. There's also one for build scans. So those are both ways to help you speed up your builds. So dpeuniversity.gradle.com.
And we'll send follow-ups on all this information. Guillaume, anything else you want to share with the community before we sign off?
Yeah, so really our journey with Develocity has been amazing. I don't think we would be as fast as we are now without it. You all have been extremely helpful. It has been really nice to work with all of you. And yeah, Brian, we use your Maven API a lot, and for the Quarkus extension, the Develocity extension, and it has been amazing. So thanks to you too for all that work. And really thanks everyone. It has been really nice to collaborate with all of you.
Awesome. Thank you all, and keep a lookout for the next DevProd Lowdown webcast. And for folks that want to come and check out our conference, we have the Developer Productivity Engineering Summit in San Francisco, 24th and 25th. We have some great talks there from the Gradle team. Brian's doing a talk there as well, and we hope to see you all there. And if not, on the next webcast. Thanks, everyone, for joining.